everybody. So today we're going to be going over the review for the test tomorrow. The test is going to go over transformations, so dilations, translations, reflections, and rotations, and a little bit about proportionality, okay? So let's take a look at this question. Triangle ABC is dilated with the origin as the center of dilation to create triangle A prime, B prime, and C prime. Create an algebraic rule, okay? Algebraic rule pretty much means the same as an algebraic representation, okay? So, we had to find the algebraic representation for this dilation. Now, one thing I know about the algebraic representation for a dilation is that you need to know the scale factor, okay? So, they don't give us a scale factor in this question, but they show us how the image was dilated, and that's all we need to find the scale factor. So what are we going to do? We're going to do our new over our original. Okay, so that means, let's take, for instance, A prime and A. So A prime is going to be our new point because it has the prime mark. So our new point A prime is at 4 and 6. So it's at 4 and 6. And we're going to divide that by the original. So here's A prime, and here is A. A is at 2 and 3. 2 and 3. Okay? So now let's go ahead and divide. Well, what's 4 divided by 2? Bring that down. That's going to be 2. And again, 6 divided by 3 is also 2. Right? So our scale factor is 2. All right, scale factor is 2. Alright? So, now for the algebraic representation, or the algebraic rule, again, they always start out as x and y, and then the arrow, again, that arrow tells me that a transformation is happening. So, what happened? How do we go from this small red triangle to a bigger one? Well, we dilated it with a scale factor of 2, okay? So our scale factor is going to go in this side of the algebraic transformation. We're going to put 2x and 2y, okay? So that's question 1. Now, question 2. A square with a perimeter of 24 units is graphed on a coordinate grid. The square is dilated by a scale factor of 8, okay? So they give us our scale factor. If xy represents the location of any point on the original square, create an algebraic representation that represents the dilation. Okay, so they're asking us to create an algebraic representation. Again, for an algebraic representation, it always starts out as x and y. Okay, and then your scale factor is going to be attached to that x and y after the transformation, right? So here's 0.8. X and 0.8 y, because our scale factor was 0.8, right? It tells us a scale factor of 0.8. Okay, so that's what we put in the algebraic representation. Okay, so triangle ABC is dilated with the origin as the center of dilation to create triangle A prime, B prime, and C prime. Okay, and again, it's asking us to create a rule. A rule is another word for an algebraic representation. So it's asking us to create an algebraic representation. Again, for the algebraic representation, you need to find your scale factor. They don't give us the scale factor, but we can find it by doing new divided by original. Okay. So again, N over O, that stands for new divided by original. So your new point, let's do A prime and A, okay? A prime, that's our new one because it has the prime mark. And again, remember, the prime mark tells us that the image was dilated or transformed, okay? Give me one second. Let me turn on the light. Okay, so hopefully y'all can see me a little bit better. So again, the prime mark right here tells me that that's my new image, okay? So A prime is at 4 and 2, and A is at where? A is at 2, 1. So let's go ahead and divide. 4 divided by 2 will be 2. 2 divided by 1 will be 2. Okay, so our scale factor, this is our scale factor now. It's not 2, 2, it's just 2. Okay, so our scale factor is 2. Now, the question isn't asking for the scale factor, it's asking for the algebraic representation that includes the scale factor. So we're going to create it. We're going to do x and y. Again, an algebraic representation always starts out as x and y. And then for a dilation, like what we did here, okay, well, what was our scale factor? It was 2. That's, again, how do we find our scale factor? We took our new over our original. We divided our new point by our original. So a prime was 4, 2, divided by our original point of a, which is 2, 1, and you'll get 2 for both the x and the y. Okay? So our scale factor was 2, so it's going to be 2x, 2y. Okay? So on to question number 4. Pentagon penta is shown on the coordinate grid. Pentagon penta is dilated with the origin as the center of dilation. Using the rule xy transforms, and you have 2x and 2y on the other side. So what's my scale factor? Well, it's the number attached to the x and y on the other side of the algebraic representation. So 2x and 2y, that tells me that the scale factor is 2. So let's go ahead and plot these points. First thing I want to do is I want to write x and y, because it's asking us to compare the two pentagons using the scale factor. Okay, so 2x, 2y. Okay, so let's go ahead and write P, E, N, T, and A. So P is at negative 4 and 3. 4 and 3. Okay. E is at 0 on the x-axis and 7 on the y, so 0, 7. Okay. N is at 4 and 8. Okay. And then T is at 6 and 1. And 1. 1. Okay. And then A is at 2 and negative 2. Alright? 2, negative 2. Alright, now they're all going to be transformed by what? Our scale factor, which is 2. So P prime will be negative 4 times 2, which is negative 8. And then 3 times 2, which is 6. So are we all seeing how I go from negative 4 and 3 to negative 8 and 6? I multiply them by my scale factor again, which was 2. So E would be what? E would be, let's see, 0 times 2 is 0, because anything times 0 is 0. 7 times 2 is 14. N is 4 eighths, so N prime would be 8. Let me draw that parentheses a little better. 8, comma 16. Okay? Again, we take 4 and 8, multiply them by 2. 4 times 2 is 8. 8 times 2 is 16. Okay? So T prime would be 12, 2. Okay? And last but not least, A prime is going to be 4, negative 4. Okay? So now, what happened? How do we go from these points to these points? We multiply by our scale factor, okay? And we know we have our scale factor is 2 from the algebraic representation, okay? So let's try and get this one. Rectangle ABCD is rotated 180 degrees clockwise about the origin to form rectangle A prime, B prime, C prime, D prime, okay? So which statement is true? So let's say that I'm standing right here. Now I'm going to rotate my body 180 degrees. Here's 90 degrees clockwise, and here is 180. So, the sum of the angle measurements of rectangle of the new one, the ABCD prime, is 2 times large as ABCD. So, what they're talking about is angle measures, right? So take a look at this angle right here. This represents a 90-degree angle, what I drew in red right here. Okay? This right here is a 90-degree angle. Okay? Now let's say I have a much bigger rectangle, like this. Okay? I have a much bigger rectangle. Now, again, what angle is right here? It's a 90-degree angle, okay? So no matter how much you dilate your shape or move it around or flip it over, the angle measurements will stay the same. So when it says anything changing about the angle measurements, you already know that's automatically incorrect because they will stay congruent. They'll stay the same. So each side length in rectangle ABCD prime is 3 times larger than rectangle ABCD. Again, if I'm standing like this, and I'm just this tall, right? I do a 180 degrees turn. I'm still this tall, right? I didn't change. I didn't get any bigger or smaller. So no, that's not it. The 2 rectangles are congruent. Okay, so again, I'm going to stand right here. Am I the same person, but just facing backwards to y'all? Yeah, so that means I'm the same. I'm congruent because congruent equals same. Okay, so that's our answer. And then, of course, the side lengths of the rectangle, the new one, are going to be 1/3 less. Again, we didn't get any bigger or smaller. Okay, so I'll continue the rest in part 2, and I'll see y'all there.